From Roy Sir Physics, I am going to teach you properties of class 12, lecture 1, electrostatics. Electrostatics. First question that I may ask you, properties of charge. Properties of charge. Minimum 4 properties I am telling. Charge are two types, positive and negative. Next, similar charge repel, opposite charge attract. Number 3 properties, charge of every body is conservative. That means for any isolated system, charge is conserved. Charge cannot be added. Charge can be conserved, means system interacting between them, but charge cannot be minimum or maximum. Initial charge and final charge must be same due to interaction. Fourth one, charge of a body integral multiple of smallest unit charge, that is the charge of a body Q equal to Ne. E is the minimum electronic charge. E is the charge of electron, that is minus 1.6 10 to the minus 19. That means charge of a body always multiple of electronic charge, that Ne. Next, number 5, charge Q is relativistic invariant. Means if a body moves with velocity of light, charge of the system remains unchanged. There is no relativistic effect observed on the charge. So this is the question. First I have talked to you that properties of the charge two types, positive and negative. Similar charge repel and opposite charge attract to each other. Charge of every body is conservative. That means, and Q equal to Ne, that is Q is the relativistic invariant. That means due to high velocity of the system, charge cannot be changed. Next thing, how can we charge? Next I am talking you how can you charge a body. Charging of a body. Charging of a body. First, due to friction or due to induction. Friction means, suppose a glass rod rubbed with silk. You are rubbing with silk, then glass will be positive and silk will be negative. That means when you are rubbing a glass rod with silk, then some electrons from glass rod going out of the glass rod and accumulated on silk. In glass will be lack of electrons, means positive charge, and silk gains electrons, so negative charge. Similarly, ebonite rod rubbed with fat, then ebonite will be negative and fat will be positive. That means some electrons will be coming out from the fat and accumulated over ebonite rod, As a result, far will be positive and above will be negative. Similarly, suppose a body which is plus charged brought near to a uncharged body, then what will happen? End point is positive, so it will be attracted all electron at the front side. The front side will be negative and back side will be positive. So this is this A is not coming contact with B, but A is not coming contact with B, but A is positive. So as a result, it is pulling all electrons at the front end and the rear end. That means that it will be positive. Since due to induction, front end will be opposite charge. Front end will be oppositely charged. So it is very nearest to the positive, and this positive is far away from this positive here. So we observe the attraction. The attractive force is more than the repulsive force. Thank you. Next, I am going to teach you Coulomb's law. I am going to teach you Coulomb's law. What is Coulomb's law? That is very important to us. Basic law in electrostatics, that is a Coulomb's law. Suppose Coulomb's law. Coulomb's law. Basic fundamental law in electrostatics. Suppose there is two charges Q, another is charge Q1 and another charge is Q2. They are separated by distance R. Now question is, since they are both positive, so they will repel. So repulsive force between them is SI system 4 pi epsilon naught Q1 Q2 by R square. If you take it vector form, then always direction of the force is along this R unit vector, along the direction of the line along the R. Now this value is 9 into 10 to the power 9 numerical value, and Q, if Q is measured in Coulomb, Q and Q2 in Coulomb, and R is in meter. R is in meter. So this is the basic law of electrostatics. A equal to 1 by F 4 pi epsilon naught Q1 Q2 by R square into R vector, R unit vector. Now question arises, what is the medium in between the two charges? I have taken this is air medium or vacuum, but suppose if you take the Coulomb's law, in presence of media K, then this force in terms of media will be original force F0 by K. That means force is reduced by K. This K is known as dielectric constant. Dielectric constant. So if you ask you, this is equation 1 and this is equation 2. Again I am telling you, what is dielectric constant? Now dielectric constant is the ratio of the Coulomb force when the system at the same position, two charges are the same position, F0 by Fm, K. K equal to F0 by Fm. But the K is the ratio of the force of dielectric constant having no dimension, no unit. So dielectric constant I have told you. Again I am repeating, Coulomb's law is the basic law used in electrostatics to determine the force between the two charges equal, if they are equal and same nature of the charges plus plus, then they will repel with the force, and this repulsive force 1 by 4 pi epsilon Q1 Q2 by R square into R dot R unit vector, and value of the 1 by 4 pi epsilon naught equal to 9 into 10 to the power 9. If the whole system Q is measured in Coulomb and R is measured in meter, then 1 by 4 so 9 into 10 to the power 9. But if you consider the CJ system, don't, it is 1. Don't take it 9 into 10 to the power 9. My question is, after that I am going to superposition principle. Before that, I am going to define with the help of this equation. Now, what is the electrical intensity in the electric field? Now, electrical field and electrical intensity. Conception electrical field. Now, electrical field and electrical intensity. Suppose you consider a charge Q. Surrounding the charge Q, we think this is the electrical field. It is extended up to infinity. As you go far away from the source of the charge, field reduces. Then field will be weaker as you go far away from the charge. Now, if I consider a test charge Q0 at the point R, at the point P, at a distance R from the point P, then Coulomb force, you can consider Coulomb force. What is the Coulomb force? Q0 by R square. Now, electric intensity means force per unit test charge. Force per unit test charge, that is equal to E vector equal to Q by 4 pi epsilon naught R square. This is 3. So, again I am telling, there is a charge Q. Surrounding this source charge, there is a electric field. At a distance R, if you put a test charge, very small amount of charge, actually test charge tends to 0, because otherwise the electric field will be deformed due to this test charge if it is very high value. So I am considering first Coulomb's law with the help of test charge and source charge. After that, force per unit test charge equal to electric intensity at that point P, which is at a distance R from the source charge Q. My question is that this E equal to Q by 4 pi epsilon, this value, this particular value is for discrete charges. This is the discrete charges. Now I am considering, suppose you consider so many charges are there, Q1, Q2, Q3, Q4 dot dot, and distance from these charges from the P, R1, then it is R2, R3, R4, then total intensity will be intensity for charge Q1, intensity for charge Q2, and intensity for charge Q3. You add all in vector with the help of vector addition. Again I am telling you, this is the source charge, creates electric field. This field is extended up to infinity. Let us consider a point of interest, that is P, which is at a distance R. Then Coulomb force is F equal to 1 by 4 pi epsilon Q, Q naught by R square. Then electric intensity is defined as the force per unit source test charge, that is E, Q by 4 pi epsilon R square. This is vector. And if I consider, let us consider 4 charges Q1, Q2, Q3, Q4. Now from the point P, distance of Q1 equal to R1, Q2 equal to R2, Q3 equal to R3 and Q4 equal to R4. In that case, total intensity at the point P will be E1 plus E2 plus E3 plus E4 dot dot En. This basic mathematical notation is known as superposition principle. Superposition principle means you add all intensity E1, E2, E3, E4 dot 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 by vector addition. Find out total intensity at the point E. All I am discussing for the discrete charges. Next, I am teaching you with the help of this Coulomb's law how to use this Coulomb's law in mathematical form. Now, suppose there is two charges, 16 Coulomb and 19 Coulomb minus. Distance between them is 8 centimeter. Question is where electric field is 0. This is the question. Again I am telling 16 Coulomb and 9 Coulomb, these two charges separated by distance 8 centimeter. My question is where is the electric field is 0. Always remember these opposite charges. So if you imagine it is the distance 8, so equilibrium position cannot be in between the two charges, because if you place any charges, then 16 Coulomb will repel and 19 Coulomb will attract to each other, and you will get the positive charge. So let us consider where is the where is the electric field is 0. So what will you do? Suppose you think that at a distance 8, that means from minus 19 Coulomb charge, at a distance x, that consider a point P where E is 0. That means if you put a positive charge, this positive charge, unit positive charge, this positive charge will be repelled by 16 Coulomb and attracted by the minus 9 Coulomb. So we have 16 by 8 plus x square equal to 9 by x square. Again try to understand. 16 Coulomb and minus 9 Coulomb separated by distance 8 centimeter. After that I am considering at a distance x from 9 Coulomb electric field is 0. That means if you put a plus positive charge at the point P, then 16 Coulomb repelling that positive charge along this direction and 19 Coulomb attracting this direction, so opposite forces. So we have this equation. Now we have 4 pi 8 plus x whole square equal to 3 by x the whole square. So we have 4 by 8 plus x equal to 3 by x, or x equal to 4x minus 3x equal to 24, or x equal to 24. That means from minus 19 Coulomb, this at a distance 24 centimeter, E equal to 0, or from 16 Coulomb we have at a distance 32, 24 plus 8, 24, this is 24, this is 8, 24 centimeter, 32 centimeter, E equal to 0. Again I am repeating this problem by using Coulomb's law. What is the problem? 16 Coulomb and minus 9 Coulomb separated by distance 8 centimeter. My question is, where is the point along the axis where E equal to 0? Let us consider at a distance x from 9 Coulomb, you consider a point P where E equal to 0. How E equal to 0? Put positive charge, then positive charge 1 repelled by 16 Coulomb by this force, and minus 9 Coulomb attracting opposite direction, so they are equal and opposite. So we have this formula and we are getting x equal to 24. So x you may give the answer from 9 Coulomb, it is at a 24 centimeter, or from 16 Coulomb, 24 plus 8, that is 32. Thank you today.